Hey everybody, it's Brian here with another SPSS video. Today we're going to do two-way ANOVAs in SPSS. We're using a new data file compared to our other SPSS videos. We'll use this one for the remainder of the videos I'll do this semester. It's about Halloween. So let's take a quick look at the variables that we're interested in, the ones that are relevant to our two-way ANOVA. So we'll switch here to the variable view tab. And our independent variables, so remembering that a two-way ANOVA, we have two independent variables and one dependent variable. So our two independent variables here, we have this variable number 4 here is the age. We have the age of the trick-or-treater. It's a categorical variable. If we look here on the values, we see that we have two groups. We're looking at younger kids, pre-K to 6th grade, compared to older kids, 7th grade and older. And then the other independent variable is another categorical variable, whether people went trick-or-treating with their sibling or not. So in this case, a 1 means they were not in a group with their sibling, and 2 means that, yes, their sibling was with them trick-or-treating. And we're interested in whether either or both of these variables affect our dependent variable, which is the number of houses that they visited on Halloween. So you go out and about, we counted how many houses they actually knocked on the doors, and we recorded that in this houses variable. So we have, let's see, 50 trick-or-treaters total, and we have these values recorded for all of them. So we can do a two-way ANOVA to see if either age or whether they went with a sibling or not impacted the number of houses they were able to visit on Halloween. So to do a two-way ANOVA, we go to the Analyze menu, and we go here to General Linear Model. And we're going to choose the first one, univariate. To me, this seems really non-intuitive because uni means 1, and we're doing a two-way ANOVA. Univariate is referring to the number of dependent variables. So we still only have one dependent variable, which is why univariate is the right choice in this case. So we come in here. Dependent variable is pretty clearly labeled here. We're going to bring over the number of houses into that field. And then it's these fixed factors. These represent our independent variables. So we're going to pull over the age category as well as the sibling category. And I always like to, even before I do anything here, I always like to go ahead and check the descriptive stats because we're comparing means, and unless we check that descriptive stats button, SPSS is not going to give us the means that we're interested in. So it's there under options. And now we're ready to choose OK and have SPSS give us our output here. So the first table here is simply a breakdown of the categories we're comparing. The age category, there's 25 in each of those. And then this sibling category, there's 25 in each of those yes/no conditions. And then we have our descriptives. So here it gives a detailed breakdown of the averages of each of these sort of combined categories. So just to look at this first row, for our younger kids, the average of those who were trick-or-treating without a sibling was about 10, whereas the average of those who were with a sibling is 20. And then this total is the average of all of our younger kids. Moving down to the second row, we see for the older kids, the same breakdown. 30 is about the average for those without a sibling. 19 is an average for those with a sibling, and then the average for all of our older kids, about 24 there. And then this total, we've broken down the sums or the total averages of our young kids and old kids. So what this is doing is it's doing the same thing for our other variable. The sibling no is about 20 versus sibling yes, and this represents the averages across all of our age groups, just comparing whether they had a sibling or not. And then this total here is the grand mean, the average of all of our trick-or-treaters across all categories. So finally, we come down to our ANOVA table, the results of our analysis. We can ignore these first two rows. These first two rows aren't really relevant for us. And of course, we have, just like we've seen in class, all of our columns here represent the sum of squares, degrees of freedom, mean square, our F statistic, and then sig is our p-value. But we're going to start here with our third row. This is the one that's interesting to us. And the p-value here says that the age category is significant, that there's a significant difference based on how old the trick-or-treaters were. So that's a main effective age. And then this other one, sibling yes or no, is saying collapsing across age doesn't matter whether you're trick-or-treating with your sibling or not. And we see this is non-significant. So collapsing across age, there's no effect whether you had your sibling there or not. And then this fifth row, the third one we're interested in, is the interaction, age by sibling. And we see here, this is a significant interaction. And so that's super interesting. That means that there's something going on between the age and the sibling variable that is impacting our number of houses visited. Then of course it has our error. I want to point out that when we've done the total in class, SPSS is calling that the corrected total. So this is, we had 50 people total. So this is our n-1 degree of freedom here. So don't be misled by this total, which includes these first two rows that we ignored. So let's figure out, we need to do some post-hocs here because we have some significant results. Let's figure out what we need to look at here. So let's try and understand this main effective age. Well, there are only 2 age categories, so we can go up to our group up here, and we don't need to do post-hocs because there's only 2 categories. We can say that the average of our younger kids, this 14.96, is significantly lower than the average of our older kids, is 24.76. And since there's only 2 categories, yes, we see a significant difference, but we don't need to do post-hocs because it's not ambiguous where this significant difference must be. And then this non-significant main effect of sibling, we can look at the table up here and we see that this is, without the sibling, your average is 20.16, and that's not significantly different from with the sibling, that's 19.56. They're not exactly the same, but they're pretty darn close. And this p-value tells us that they're not significantly different. But it's this interaction that is most interesting to me. And so we can sort of eyeball these cell means. We see that young kids with a sibling went further than young kids without a sibling. We're seeing sort of the opposite pattern with the older kids, that older kids without a sibling went further than older kids with a sibling. So that's kind of what we're looking at here, but we can get a better idea of the pattern of this interaction by doing simple main effects tests. The easiest way to do that in SPSS is to split the file on one of our variables. And then since we only have 2 levels of the other variable, we can just do some t-tests to see how that shakes out. So let's give that a try. We've already have the age as sort of the way we've broken that up here. So let's split our file based on age. We could do this either way, but since we already have it, the table thinking this way, this is going to be the one that's sort of most intuitive based on how we've already been thinking of that. So we're going to split the file based on age. Now, any analysis we're going to do is going to do one analysis for one age group and then the same analysis again for the other age group. So now we can do some t-tests and compare whether traveling with a sibling or not mattered. These are independent samples t-tests. We're going to break this down by our trick-or-treating with a sibling, which was, I think, 0 and 1. And then we're going to pull over our DV, number of houses visited. And it was not 0 and 1. Lovely. Good thing I'm not recording this or anything. Let's go back and switch this. We'll call this 1 and 2. There we go. So it's doing 2 t-tests for us. So first it's showing us just for the younger kids. And here's our t-test. And so this is a big difference. Here's our comparing the 10 to the 20, big difference, significant difference, t-test of -7, or t-obtained of -7. And then we go down and does another t-test, this time for our older kids. This is another big difference, big significant difference. But notice this is a positive t-score, whereas the one up here was a negative t-score. So we can say that basically, whether you have a sibling or not affects older and younger kids differently. We can see here the older kids, when they had a sibling, they tended to go to fewer houses than when they didn't have a sibling. And then for the younger kids, having a sibling let them go to more houses than when they didn't have a sibling with them. And so that is the pattern of the interaction that we're seeing here with this result. And this splitting file and doing the t-test is a good way to see the pattern of that interaction. And obviously interactions can come in all sorts of patterns. And so it's a simple effects test that allow us to chase out exactly what that significant interaction means. All right, well, thanks for watching, and let me know if you have questions, and I'll see you in the next video.